Добре. Okay, we are waiting for our participants, and I think we will start in 1 minute. If Maksym Makaruk is here, Maksym Makaruk, Alexei Nazarov.
Makaruk.
Oh, sorry. Maksym Makaruk, Alexei Nazarov, Igor Shubin, and Nadezhda Shanidze with their research about knowledge representation method of object recognition in nuclear radar system. If you are ready,
yes, I am present.
Okay. You can share your presentation and we'll start.
I can try this. The research is about knowledge representation method for objects recognition in nonlinear radar systems performed by Maksym Makaruk, Alexei Nazarov, Igor Shubin, and Nadezhda Shanidze from National University of Radio Electronics. The main topic of this research is using the mathematical apparatus in developing methods of intellectual processing of radio location data. So there are two methods developed. The first is correlation filtering algorithm in nonlinear radar systems. We propose the procedure of synthesizing an optimal algorithm for detecting a nonlinear object by the method of nonlinear radar against the background of additive noise and interference caused the influence of the above factors. We use the criterion of Neyman-Pearson that is traditionally used in radar, which means that our goal is to minimize the probability of false alarm in our process of object detection. The optimal filter receiver, the detector calculates the values of the correlation integral and compares them with the threshold to make a decision about the presence of an object. This correlation integral is determined by the next expression, number 1, which contains two parts. The X part is expected response signal from nonlinear object, and the second Y part, which includes the random part, which is unremovable internal and external noises of radar receiver, which have a probabilistic irregular nature, and the regular component that is caused by regular components of emitted signal and regular external interference. The main point of this algorithm is that we can eliminate this regular component by the next method with constructing the detector next way. We can eliminate this regular component. In this scheme, we can improve the quality of signal by eliminating this component if we subtract the multiplied regular component and then move it to threshold that can tell we have object in front of us or no. These two correlation integrals shown the path of the first and the second channels, and the resulting correlation integral that doesn't contain mutually exposed components is presented here. The physical interpretation of this procedure is presented in figure 2. Here we can see that the area of false alarm probability is limited by a specific probability density function and the threshold. Here we can see the formula for calculating the for false alarm probability due our name on person criterion. And also we show how the role of regular component plays in our detection process. The parameter h that is showing the ratio between the threshold and a regular component is dependence to this ratio is shown in this figure. This means that lowering it helps us to improve the quality of our radio systems. I will be quicker for the second algorithm. It's quasi-optimal algorithm for nonlinear radar information processing, which the principle of operation of nonlinear ligature is based on the fact that when objects containing nonlinear elements are irradiated, the energy of emitted signal is converted into the energy of higher multiple harmonics. And the response signal counted in nonlinear elements are registered by a detecting device regardless on operating mode of nonlinear objects. So it means that we have detector of this multiple higher harmonics, which is used this combined frequency. And due to nonlinear radar properties and non-linear an object with nonlinear electrical properties, we have to satisfy different criterion to construct the well-working detector. These conditions is the choice of some parameters, such as frequency of a heterogeneous receiver, which is should be the difference to the combination frequency of a region from nonlinear element.
Sorry, I must remember you about limits of time.
Yes, I will be quick. And the second important requirement is a nonlinear radar is a choice of a receiver local oscillator frequency, the value of 2 times of first frequency. To perform this was prepared a practical experiment. The equipment of it is presented in this slide. And here we can see a block diagram of a constructed detector, which consists of modulator, 2 conditional height frequencies, multiplier by 2, which was a minute higher, the receiver, the broad antenna, which is doing the emitting signal, and the object that we need to detect. I can say that experiments show that our radar system works correctly as it was prognosed. In the conclusion, I can say that the full versions of text and presentation are presented in conference site and YouTube channel. And there was developed 2 algorithms which can be used as basis for intellectual analysis of radio location data. Thank you for your attention.
Thank you for your research. Any questions from the audience? Maybe I have one. What information technologies have been chosen to implement your method?
As I said, we constructed the receiver to show that our method is working successfully, and it can be used in modern intellectual systems of detecting flying objects.
Okay, thank you for your answer. Any question? Any other question from the audience? If you have no questions, then next speaker is Yevgen Sidenko. Thank you. Yevgen Sidenko, Tetiana Misiuk, Galyna Kondratenko, and Yuriy Kondratenko. If you're ready, you can demonstrate your presentation.
Yes, we are ready.
Okay.
Just a moment, please. Do you see my presentation?
Yes, everything is okay. You can start.
Good. Good afternoon, dear participants of the Colins conference. Would like to present you a research on the topic object segmentation in augmented reality environment by Yevgen Sidenko, Tetiana Misiuk, Galyna Kondratenko, and Yuriy Kondratenko from Petromohila Black Sea National University. Let's start. Yes. The creation of applications using augmented reality today does not require a lot of resources, so all the necessary materials and tools can be found in the public domain. However, the question arises about the quality of such projects and their practical applications still remain. At the moment, the most common use of augmented reality is in game development. However, the use of augmented reality in education is gaining more and more popularity. Segmentation can be used for object recognition, estimation of occlusion boundaries in images, and we can edit them with segmentation and search for similar images in databases. The problem in this case is the number of tasks that must be processed by the system of the mobile device. Related works. Image segmentation can be a powerful technique in the early stages of diagnostic and treatment pipeline for many conditions requiring medical imaging, such as CT or MRI. In fact, segmentation can effectively separate homogeneous areas, which may include critical organ pixels, lesions, and the like. It's quite difficult to find popular mobile applications that use image segmentation algorithms. For example, we found Skin Scan app, mobile app that uses additional accessories such as microscope for mobile phones. We study these algorithms. The mean shift algorithm groups objects with similar features. Pixels with similar characteristics are combined into one segment. The output is an image with homogeneous areas. So on the figure 1, you can see the result of the mean shift algorithm on the graphic. The Grep cut segmentation algorithm is an interactive object selection algorithm developed as a more convenient alternative to magnetic lasso. To select an object, the user needs to trace its outline with the mouse. For the algorithm to work, it is enough to enclose the object together with a part of the background in a rectangle, Grep. It is shown on the figure 2. The k-means method is the simplest and most common clustering method. The purpose of the algorithm is to split the input image with n pixels into k clusters, where k is given by the user. Clusters represent some grouping of pixels, which depends on the values of pixels in the picture, but does not necessarily depend on their location in the original image. Implementation of object segmentation algorithms. The OpenCV plugin for Unity was used to create the application. It was decided to create a mobile application for iOS 10 and higher. Test launches of the application were carried out on just such a device, and it is assumed that with the expansion of the functionality and quality of the application, it is possible to create applications for other mobile operating systems. K-means algorithm implementation. To get a finished image that will be segmented, it is necessary to combine images from all these clusters embedded in the whole image. So on the figure 4, you can see the result of clustering with K-means at the second part of the image. Grep cut and mean shift algorithms. The Grep cut algorithm turned out to be the best algorithm for image processing. The processing result was the closest to the expected one. Although the algorithm has some errors, despite the fact that the area that was contoured turned out to be the clearest and most complete in comparison with others algorithms, this area also includes areas of the image that do not belong to the objects under study. And the result of processing by the Grep cut algorithm you can see at the figure 5a, and the result of processing image with the min shift algorithm you can see at the figure 5b. These algorithms were used to segment images on a mobile device. By improving these algorithms, you can achieve good image processing speed on portable devices. By using an app for mobile devices that segments images in real life, technology can be more involved in the learning process of school children and students by creating special apps for these groups. So, conclusions. As a result of the study for object segmentation algorithms, an AR application for mobile devices was created using the OpenCV library for image processing. The following image processing algorithms were tested: K-means, min-shift, and grep-cut. The best result was obtained using the grep-cut algorithms. The OpenCV library uses scripts written in C++. For such cases in the Unity 3D environment, there is support of plugins that allows to use in the code functions from the given libraries. Analyzing the obtained results, we can conclude that for image processing on mobile devices, it is necessary to use algorithms that do not require large resources and can quickly display the result on the screen. The use of image processing algorithms in augmented reality mobile applications makes it possible to create virtual scenes with great detail and better interaction between real objects and virtual ones. So that's all. That's the summary of the research. Thank you.
Thank you for your research. If our audience have any question.
Can I? Tetiana, I have one question. Tell me, please, which another applications of the object segmentation did you know?
There is a lot of applications that are used at the medicine, but for these applications, you need some additional devices such as a microscope and maybe other stuff to perform some actions, some little details for the image
Okay, I
processing.
understand. Okay, thank you.
I also have two little questions about you choose the clustering algorithm, yes, one. And what about analysis? Have you any analysis to other clustering algorithm in your work? And it wasn't not clear maybe for me for what kind for which type of mobile device in this software product is adapted.
We research three algorithms: the K-means, min-shift, and grep-cut. It was the algorithms that are easily to implement on the mobile devices and easily to calculate the result of the segmentation with these algorithms. And the application was created for mobile phones, iPhones, was built on the MacBook for iOS 10 and higher for mobile devices.
And comparison with other similar application was made or no?
We just search in the internet some applications, but there is for some applications there was no possibilities to try these applications because they have price. Yes.
Yes, because I read your article and I didn't find this answer for my questions. Thank you for your research. We can move on and move to next speaker. If you're ready, it's Olga. You will go. No.
I'm here.
You will read our next participant, or I can.
Natalia Boyko and Andrei Patel.
Okay.
Maybe.
They are not, unfortunately, they are not here, and we must move next to another speaker. So it would be
Lesia Mochorot.
and so unfortunately they are not here. Okay, maybe it's if Olesya and Natalia Boyka, Andrei Pitel are not here. So maybe, I don't know. Maybe we will have a little rest until 3 p.m. Yes?
Yes, I agree.
I agree with you. And so we will go to the same link at 3 p.m. and we will start our new hour session. Thank you.